So good afternoon or good morning to everyone, and thanks to Chris and Nadine for allowing me to speak at the workshop. And basically, I'm going to take a different perspective. So I'm speaking from an institutional background. We're talking on an institute, which is the National Institute of Space Research in Brazil. And Chris invited me to talk to you about why INPE is embracing cloud native geospatial. So let me first tell you who INPE is. INPE is Brazil's National Institute for Space Research, and we do among the many things we do an important bit, which is providing official land use and land cover information about Brazil. So when you read the New York Times or the Guardian or Le Monde that the deforestation in Brazil is soaring, this is based on INPE's data. We have different services that use remote sensing data to tell about deforestation in Amazonia and in the other biomes of Brazil. And this is done from 1988, so we have more than 30-something years of work on this. Now, we decided to move to cloud native geospatial because in the availability, substantial availability of the data, which is now available on cloud services, allows us to create data cubes. And data cubes are very important to serve as a foundation for data analytics. It also allows to be used extensively for the researchers. And what we found is that, of course, there is the work of doing data cubes is be done is if it has to be done for every researcher who accesses the data which is available on Amazon or which is available on Microsoft, turns out that the same work is done many, many times. So one of the points of the data cubes is to produce regularly spaced data cubes and well-defined tiles and well-defined resolutions for collections of satellite data and sensors which are available for the Brazilian territory. So basically this involves the CBUS-4, this is the Chinese Brazilian Earth Resources satellite, which has a sensor at 64 meters, a Landsat 8 and Landsat 9 now, and Sentinel-2 and 2A, and so the CBUS will be at 64-meter resolution, Landsat at 30-meter resolution, and Sentinel at 10-meter resolution. So all the bands are normalized to that resolution, and all the tiles are organized in 16-day temporal composites. So essentially what you have data cubes covering Brazil at different times and essentially been available since 2016. And the data is available on the web, downloadable, but also we provide, of course, a cloud service of people who use very similar to Google Earth Engine, but only with two differences. One is that the data is organized as data cubes. The other is that there is a package called SITS, which is short for Satellite Image Time Series, which actually you can use to analyze the data on the Brazil data cubes. In fact, SITS uses a lot of STAC, thanks to Chris. In fact, we maintain the only current implementation of STAC for the R language. We mostly use R, and with STAC we can actually access not only the Brazil data cube, but also Earth on AWS, Microsoft, Digital Earth Africa, and others. Anything that which makes its data stack readable, we can access it and use it. And we believe that when has to use, in order to do accurate work of land use and land cover, all the data available. So instead of using one image, for example, one best image per year, we use a whole satellite image time series. And we have, of course, the ability of training and the ability to produce land use and land cover maps. To do so, we have a fairly sophisticated package that does a lot of things, regular land, starting from regularizing Earth observation data cubes when they're not regular, doing quality analysis using self-organized map, diverse methods of machine learning, including very state-of-the-art models for convolutional neural networks, and also attention-based models for those who know what is this, and also methods for post-classification based on Bayesian analysis to produce accurate land use maps. And the result is that we can classify big areas. We're talking about, for example, 200 million hectares, which is roughly half of the size of Europe, land use map using the temporal convolutional neural network models with 50,000 samples, using Landsat with 8 terabytes processed in a reasonable machine in 24 hours with 80% accuracy. So what we do in Brazil, we have not only organized the data based on STAC, but also provided that as observation data cubes and developed data cube analysis software. And that's it.